Okay, this is page 14. Basically, box plots are compared to other box plots quite a bit. Here's a picture where they're going vertically. You can see how they change. I'm not sure what this axis is, but you can compare all of these. You can see outliers here. This actually has outliers on both ends, and that could be important. Here's another one that compares several box plots. They're horizontal, and you can also see some of the outliers here. You could look at the middle 50% of the data. You can see how spread out the data is. There's a lot of things you can do with it. Really quick, I want to show you how to do this on your calculator to create a box and whisker plot on the graphing calculator. I already have the boys and girls data in here, so I'm just going to work with that. I have it in list 1 and list 2, so I'm going to just go to second stat plot, and I've already we had used this for the histogram last, so I'm going to turn it on here, jump down to the type, and I'm going to hit the right arrow till I get to, actually there's two different kinds of box plots. I want to do the fifth one first, and if you notice, one box plot doesn't have any dots in it, and the other one does have a dot. So this is the basic box plot, and this is the modified. Actually, we would always use the modified, so I'm going to bounce back there. Let's just do the modified. If you want to see it without being modified, you can do the other one, but we'll use the modified one. I forgot to hit enter. Okay, so now we can see what data values what list names we need to enter. So let's use the girls list, because the boys list didn't have any outliers, so it's less interesting. We'll do second list 2, and the frequency list, actually there is no frequency list here. We'll leave that blank. Actually, we'll put a 1 in there. Sometimes you leave it blank, sometimes you need a 1, but we'll put a 1 in here for the graphing purpose. The 1 just means each data value is in there one time from the list, and then you can decide what the mark is going to be for the outliers. Anyway, so we're good to go here, and I need to, anytime you're building a graph, you want to use zoom stat, and it'll basically set up the window to be in the best form it can be in. So zoom, it's actually zoom 9, zoom stat, and there's the girls box plot along with the graph I still had on my y = screen. I forgot to take it off. Let me get rid of it now. I'm going to hit graph again. There we go. I'm going to hit zoom stat again. Well, it put it in the same place. I thought I would move it down. Anyway, so there's our graph. There's our outlier for the girls. Now you can actually plot more than one plot at a time. I could go to plot 2 here, turn it on, make a modified box plot. I could put the boys data in there, which is actually list 1. It's already ready to go. Do zoom stat again, and there's the boys and girls. They're together. Let's compare that to ours. Wrong one. Compare it to those two. And it's not bad. Alright, so that's how you make a box plot, and you can do up to 3 on the page at a time. You can even do a histogram and a box plot, and that's on this page. You can see some other examples of that. It actually is an important skill to be able to compare box plot results to a histogram result. So there's an activity for you to try, an applet to play around with that, and you can do multiple simulations or generate new random values, and it'll give you all different types of histograms and box plots together. But look at this one. I like this because you can see the histogram is definitely skewed right, but now here is the box plot. Think about this. This space right here is 25% of the data. This space right here, this skinny bar, represents 25% of the data. So together, this space in here represents 50% of the data, which is probably about how much space that bar takes up in terms of the frequency, the height of that. All the way up to here, 75% of the data. So there's very little data here, and that's why it's spread out. Then you got these outliers beyond the fence here because they are unusual values on this severely skewed distribution. Okay, that's it for today's video. Follow the notes on Canvas to see the rest of the assignment.